Air brakes hiss. The grade drops away. 80,000 pounds of freight surge forward, and behind the cab, 22 feet of hardwood floors and plumbing ride on a stretched Kenworth W900L. Engine brake engages first. The Cummins X15 roars in restraint, converting speed into resistance. The tachometer climbs. Brake temperatures begin their slow rise. Crosswinds press against tall sleeper walls built wider and heavier than factory steel ever anticipated. This is not an RV. It is a working semi hauling an apartment down a 6% mountain descent. And this is where extreme sleeper trucks reveal what they really are. Gravity does not recognize marble countertops. It does not respect recessed lighting or king-size beds. It tests weight, balance, and heat. The Kenworth carries a custom-built living module extending well beyond standard sleeper dimensions. Inside, porcelain fixtures, a full refrigerator, insulated water tanks, and climate control systems independent of engine idle. Outside, tandem axles recalibrated for added mass, and air suspension tuned to absorb oscillation without allowing sway. As the descent continues, retarder settings adjust. Heat radiates from brake assemblies. The driver watches gauges instead of scenery. Extreme sleepers began as a response to endurance. Long-haul operators spending most of the year on the road wanted more than a narrow bunk behind the seat. Builders answered by stretching frame rails beyond 300 inches, reinforcing cross members, and redistributing weight so axles could support both freight and habitation. The ARI Legacy 220 sleeper became one of the defining statements. 220 inches of integrated living space mounted behind a Peterbilt 389. Solid cabinetry secured with vibration-resistant hardware. Freshwater and gray tanks mounted between rails like hidden ballast. Electrical systems powered by dual alternators feeding battery banks large enough to sustain residential appliances. On level ground, it feels architectural. On a mountain descent, it feels consequential. Add 10,000 pounds of structure and the center of gravity shifts rearward. When the truck leans into a curve, inertia pulls differently. Air suspension must respond instantly, absorbing roll without overcorrecting. Too much rigidity fractures joints. Too much compliance invites instability. Engine braking holds steady, but speed creeps higher as the grade steepens. Heat is the invisible adversary. Brake fade does not announce itself dramatically. It arrives gradually as friction surfaces saturate and stopping distances lengthen. That is why heavy-duty sleepers rely on layered control. Engine brake first, retarder second, and service brakes last. Luxury only survives if control systems remain disciplined. Farther along the same descent, another build enters the frame. A Volvo VNL conversion carries a fully integrated motorcycle garage. Hydraulic rear doors conceal a Harley-Davidson secured above reinforced flooring. The sleeper stretches nearly 45 feet in total length, transforming a streamlined tractor into a dual-purpose platform. Volvo's D13 engine pairs with the I-Shift automated transmission, modulating torque with precision. Stability systems monitor yaw and lateral load as crosswinds sweep through the valley. The expanded sleeper profile presents a larger surface area to the wind, amplifying side pressure. In a long curve, the added height shifts sensation inside the cab. Steering input becomes deliberate. The relationship between the front axle and the extended rear mass tightens. Behind the driver, climate systems hum quietly. Insulation dampens vibration. Cabinetry remains composed. The motorcycle sits immobile in its compartment. The descent continues. Speed is controlled, but momentum never disappears. Every pound carried behind the cab must be managed through physics, not appearance. Some extreme sleepers are built not only for comfort, but for coordination. A custom Peterbilt, 389, configured as a mobile command center for competitive pulling circuits, carries tools, spare components, compressors, and crew quarters within its extended structure. Bright paint and polished chrome conceal practical engineering beneath. Above reinforced compartments, bunks allow team members to sleep while the truck travels before dawn. Below, equipment is secured against constant vibration. Powered often by a Caterpillar C15, delivering more than 550 horsepower, these trucks must haul heavy trailers while protecting the integrity of their interior systems. Manual transmissions demand precise timing. Engine braking carries sustained responsibility on long grades. Descending under full load, the margin for complacency narrows. Brake temperatures rise incrementally. Transmission oil warms. The driver monitors coolant levels, axle weight distribution, and tire pressure data. Fatigue amplifies small errors. A delayed downshift. Excessive brake application, a momentary lapse in attention. Extreme sleepers are not immune to the realities of commercial hauling. Their additional mass increases stopping distance. Their extended frames require careful maneuvering through tight curves and traffic compression zones, and still the descent persists. The most structurally audacious example arrives in Cabover form, a Freightliner Argosy converted into a 32-foot two-level sleeper module. Cabover architecture places the driver directly above the front axle, compressing feedback into immediate sensation. Steering input is direct. Road imperfections transmit upward without delay. Behind it stretches a multi-level living structure with upper loft windows, a full living area, and a complete bathroom insulated against vibration extremes. Detroit diesel power flows through a 13-speed manual transmission. At highway speed, lateral wind pressure acts on the tall sleeper body. Suspension geometry works continuously to preserve balance between the front axle and the extended rear structure. In tight descending curves, the relationship becomes dynamic. Weight transfers forward under braking. The rear mass pushes subtly against the tractor. Steering corrections are small but constant. Every input matters. Inside the sleeper, the environment remains unexpectedly calm. Cooktops are secured. Water heaters cycle. Electrical systems convert stored power into steady current through inverters mounted beneath reinforced flooring, but none of it changes the descent. Gravity persists. Engineering answers. Extreme sleepers demand comprehensive system thinking. Electrical loads must be calculated to avoid overload. Plumbing lines require insulation against both freezing temperatures and vibration fatigue. Cabinetry joints are reinforced like marine installations. Slide-out mechanisms rely on hydraulic precision to prevent misalignment over time. Each added feature compounds mechanical responsibility, and yet owners continue commissioning them because long-haul driving is isolation measured in miles and nights. Standard sleepers offer minimal privacy and limited recovery space. Extended sleepers create autonomy within motion. They do not eliminate risk. They redefine living conditions within it. The descent reaches its final miles. Brake temperatures stabilize under disciplined control. Engine braking maintains resistance. Speed remains within range. The truck levels out. Air systems equalize with a measured release. Heat dissipates from rotors. The driveline relaxes into steady cruise. Behind the cab, the living space remains intact. Hardwood floors unshaken. Water tanks secure. Electrical systems stable. Extreme sleeper trucks exist at the intersection of habitation and heavy industry. They stretch commercial platforms beyond factory assumptions while remaining legally compliant and operationally capable. As emissions regulations reshape diesel engines and automation systems advance, the sleeper may become the defining human environment within freight transport. Lane-keeping systems and collision mitigation already assist drivers. Future autonomy may shift the balance further, But for now, the descent still requires judgment. It requires understanding of weight, heat, and restraint. And at the end of the grade, when the truck settles into level highway, the transformation becomes visible again. Hydraulic slide-outs extend at rest stops. Interior lights glow against insulated walls. Refrigerators hum. Showers run warm. Outside, rows of conventional tractors idle beneath sodium lights. Inside these extended chassis, space expands. 40 feet of reinforced steel supporting a structure never imagined in original blueprints. The road remains indifferent. The engineering answers. And somewhere beyond the next mountain pass, gravity waits again.